Hi, this is Ms. Conley, and I'm going to go through this problem involving complex roots of a polynomial equation. So we have given that 2 plus 3i is a root of z cubed plus az squared plus b equals 0, where a and b are real numbers. Find all of the roots to this equation. Okay, so right away we should recognize that we have a cubic equation, which means we're looking for 3 roots in total. And since one of the roots is complex, that means that we have to have a second complex root as well, because those come in pairs. So we know right away that 2 of our roots are 2 plus or minus 3i. We need the complex conjugate of the given root, so that's the 2 minus 3i. Which means we have one remaining root, which has to be a real number root. So let's just call that x. That stands for our real root. And to answer this question, what we need to do is find x, figure out what this real root is. Okay, so let's start out by forming a quadratic factor of this polynomial equation based on the 2 given roots that we have now. So if 2 plus 3i is a root, that means that z minus 2 plus 3i has to be a factor of the equation, as well as z minus 2 minus 3i, the other root. Okay, so these both have to be factors of the equation since we have these 2 given roots. Before we expand this, let's regroup it a little bit. Let's write this as z minus 2 minus 3i. And then this second one in a similar way as z minus 2 plus 3i. Make sure we distribute that negative there. Okay, so now when we expand this to form our quadratic factor, we have z minus 2 squared. And then our middle terms, we have z minus 2 times a positive 3i, and then z minus 2 times a negative 3i. So those middle terms are going to cancel. And then we have negative 3i times 3i gives us negative 9i squared for our last term. Okay, so now remember that I squared equals negative 1, which means that this is just a plus 9 here. And if we expand this out, we have z squared minus 4z plus 4. Okay, combine those like terms, means our quadratic factor is z squared minus 4z plus 13. Okay, so this is the factor that gives us our 2 complex roots, which what we're missing now is this other factor that will give us our linear root. So we'll call that z minus x because x is our root, which means that z minus x has to be a factor of the equation. Okay, so now we know that this has to be equal to the given polynomial, z cubed plus az squared plus b. What we have on the left side is just the factored form of the given polynomial. Now if we knew what a and b were, we could go ahead and do polynomial long division here, but we don't know those values. So instead of doing polynomial long division, let's expand out the left side of the equation and see if we can find x that way. Okay, so when we expand out the left side of the equation, multiplying the quadratic factor by the linear factor, we get z cubed minus xz squared minus 4z squared plus 4xz, plus 4xz, where am I, plus 13z, and minus 13x. Okay, and that still has to equal the right side of the equation, which is z cubed plus az squared plus b. Okay, now if we notice the right side of the equation, we have a z cubed, a 1z cubed, we have the same thing on the left side. Our az squared, well, since we don't know what that coefficient is, that's not going to help us find the value of x. And then our constant term is just b, but again, we don't know what this constant is, so that's not going to help us find x either. But notice that we're missing a z to the first term on the left side of the equation. So let's say that, on the right side of the equation, since we're missing that, let's say that this is a plus 0 z to the first, and let's see if we can use that information to find x. On the left side of the equation, there's 2 terms that are making up a z to the first, and that comes from this term here, the 4xz, and the 13z. Those are the 2 terms that will make up the z to the first. So we know that 4xz plus 13z has to equal 0z, which means that our coefficient here, 4x plus 13, has to equal 0. So this equation we can now easily solve for x, and we get that x is equal to negative 13/4. So that's our third root. So to answer the question, we were asked for all three roots of this, we were asked for all of the roots, and we know that there's 3, so our roots are 2 plus or minus 3i, and then our third root, which was our real number root, is negative 13/4.